Assalamualaikum and hi, my name is Muljana binti Ismail. My matrix number F1096. This is our project design. Type of building, double story house building, simple structure. Facility, we have room, kitchen, toilet, living room, garage and family area. For location, number 73, Jalan Rambutan 2, Bandar Sri Putra 4300, Kajang, Selangor. Next, this is our structural plan. Number 1, we have roof plan. Number 2, we have first floor plan. Number 3, we have ground floor. And lastly, we have pet food. Next, we have elevation plan. Number 1, southwest elevation. Number 2, southeast elevation. And number 3, front elevation.
Okay, Assalamualaikum warahmatullahi wabarakatuh. This project involved the design of a double-story residential house located at number 73 Jalan Rambutan 2, Bandar Seri Putra, Kajang. It constructed with C20/25 concrete, designed for a 50 years working life, and classified under exposure class of XC3 for its structural elements and meeting a minimum fire resistant rating of R60 to ensure durability, safety and long-term performance.
Introduction. Reinforced concrete design focuses on combining concrete and steel reinforcement to create structures that are strong, durable and able to resist different types of loads. Concrete provides excellent compressive strength, while steel offers high tensile strength, making the combination suitable for elements like beams, slabs, columns and foundations. This design approach ensures that structures meet safety, serviceability and durability requirements in modern constructions. For me, I designed a two-way restraint slab. My slab panel is at B2. My span length is 5.6 meters. My slab type LY per LX 6.12 per 5.60, and I got 1.09. It's for a two-way slab, not more than 2, and my thickness H is 200 mm. Bar that I use is 10 mm. Concrete grade FCK 30 Newton per millimeter per square. Steel grade FIK I use 500 Newton per millimeter square. Concrete cover Sinom I use 35 millimeter. Permanent load GK I got 7.3 kilonewton per meter square. Variable load QK I got 2.50 kilonewton per meter square. My design load ND equal to 13.61 kilonewton per meter square. For my case is case number 4, to adjacent edges discontinuous. For my movement, MSX1 I got 15.37 kilonewton per mm. MSX2 I got 20.10 kilonewton per mm. MSY1 I got 14.51 kilonewton m per meter. For MSY2 I got 19.21 kilonewton m per meter. And for shear, for VSX1 I got 25.31 kilonewton per meter. VSX2 I got 18.40 kilonewton per meter. VSY1 I got 28.31 kilonewton per meter. For VSY2 I got 18.40 kilonewton per meter. For VRD, I got 150.33, small, bigger than VED, 86.75. For my deflection, my actual is more lesser than allowable. So for actual I got 35 and allowable I got 139.70. For cracking main bar, my S actual is 300. It's more bigger than S allowable, 450. It's more lesser than my S allowable for 550. And for my detailing, long span, for main bar I use H10 250, secondary bar H10 300, and for short span My main bar is H10 300, support bar H10 300, and secondary bar also H10 300. Thank you.
Assalamualaikum. My name is Tamia Bagus binti Akram. My matrix number is F1069. Next, two-way resistance slab. This is a two-way resistance slab because the long span to short span is less than 2, and the thickness is 200 millimeter, and the diameter of bar is 10 millimeter. Concrete grade FCK equal to 30, and steel grade FIK equal to 500, and the concrete cover CNOM equal to 35 millimeter. The permanent load GK equal to 6.30, and variable load QK equal to 2, and the design load equal to 11.55. And the next one for moment in the X direction equal to 14.68 and 19.68. For the Y direction equal to 10.62 and 14.06. Next, shear in the X direction equal to 28.18 and 18.59. In the Y direction equal to 23.99 and 15.59. And BRDC equal to 69.78, higher than VED equal to 28.18. So the shear is safe. And next, for the deflection checking, the actual span to depth is 33.56, and the allowable is 87, and actual is less than allowable, so the deflection is okay and pass. Next, cracking, as actual equal to 300 millimeter, and as allowable equal to 450 millimeter, and the as actual is lower than the allowable, so the cracking is okay. So the next one is detailing. For long span, the main bar is equal to H10 300, secondary bar is H10 300, short span, the main bar is equal to H10 300, support bar equal to H10 300, and secondary bar equal to H10 300. Conclusion. In conclusion, this study on slab construction highlight the importance of proper planning, accurate measurement, and the correct selection of materials to ensure structural strength and durability. Each stage, starting from formwork preparation, reinforcement placement, to concrete casting, must be carried out carefully to prevent defects such as cracking, uneven surfaces, or structural weaknesses. By following the correct procedures and complying with engineering standard, the slab can perform effectively in supporting loads and ensuring overall building stability. This study projects also enhance understanding of practical construction processes and strengthens awareness of quality control on site.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aizat. My matrix number is F1087. So today I will present about beam. The first one is specification. The effective length is 6.91 meter. After that, fire resistant R60. Exposure class is XC3. Second, material. FCK 30, FYK is 500, and our beam assumed bar is, for assumed bar 1 is 20, the second one is 60, and the bar length is 6. So for our beam size, BH is 250 and 550 mm, and then in the durability, fire and bond requirement part is our ASD is 40, CNOM 35. And then about loading and analysis, the characteristic permanent action GK is 10.74. After that, the characteristic variable action for QK is 3 kNm. After that, load on beam to AC. The beam self-work GK is 27.23, and then the QK is 6.157, and then the shear force is 161.07, and then the bending moment is 278.25 kNm. And then in the main reinforcement part, the K is smaller than K balance, so we got AS for 1606, and then the AS minimum is 156, and then the AS maximum is 5500, and we use 6H and 20. 6 is from bar link, and then the 20 is from the table. So shear reinforcement, we use H6200, and then we use H6300. So for the additional tensile force, the FTD is 201, and then the AS is 462 mm square. So in the deflection part, our allowable LD allowable is 17, and then the LD actual is 14. So 14 is smaller than 17, so the result is okay. Our deflection is okay. And then the last one is cracking. Our steel stress FS is 233, so max allowable bar spacing is 300, so our bar spacing is 79. So it's okay because 79 is smaller than 233. That's all. Thank you. So in the conclusion, the beam construction work demonstrate how crucial proper preparation, accurate reinforcement placement, and correct concrete handling are to achieve a safe and reliable structural element. Beams play an essential role in transferring loads to columns and foundations. Therefore, every step from formwork installation to steel bar arrangement and concreting must follow engineering standard and quality procedure. This project reinforces understanding of structural behavior while emphasizing the importance of workmanship, monitoring, and safety on site. Through this activity, the team gains valuable practical experience and awareness of how proper beam construction contributes to the overall stability and performance of a building. Thank you.
Lastly, I want to present non-slenderness column. Column I/1. Column type non-slenderness column. Size of the column 150 multiple 150. Bar use 20 mm. Concrete grade FCK 30 N per mm power of 2. Steel grade FYK 500 N per mm power of 2. Concrete cover CNOM 35 mm. Axial force 140 and bottom 4.78 and top 5.78, moment 5.5 2 kNm, S mean 26 mm power of 2 or 45 mm power of 2. This is detailing for the non-cylinderness column. Use 4H60 8004 mm power of 2. And then link we use H6 240 and H6 140. Column. The design of the non-cylinderness column has been successful, complete based on the given structural parameter. With a column size of 150 multiple 150 mm, concrete grade FCK equal 30 N per mm power of 2 and steel grade FYK equal 500 N per mm power of 2. The column is capable of safety resisting the applied axial load and bending moment. The final reinforcement provided 4H60 804 mm power of 2 as main bar and H6 linked at 140 mm and 240 mm spacing meets the minimum steel requirement and ensure adequate strength, stability and ductility. Overall, the detailing and reinforcement certify the design criteria for a non-cylinderness column and ensures safe structural performance.